Hello class. So this is Calculus, Math 1430, and we're going to talk about differentials. My name is Doug, making a rare appearance instead of my brother. So differentials, they're good for estimating things like how about the square root of 49.1? We don't know what that equals. We could use a calculator, but let's do it by differentials, and we'll see that this answer by differentials will be extremely close to the actual calculator answer. So what you want to do in this case is, since I see a square root, let f of x equal the square root of, and then use the variable x. Okay, and by the way, if this were a cube root, then that would be a cube root. And let's remember this formula, dy equals f prime of x dx. Basically, it comes from dy dx equals f prime of x. And then multiply both sides by dx, and you get that. Okay, so let's let x equal 49, since my radicand here is close to 49, 49.1. And isn't 49 a perfect square? So we know the square root of 49. We don't know the square root of that, though. So that's the key step, to let x equal some number close to this number, and something that you know. So we do know the square root of 49, since 49 is a perfect square. So we know square root of 49 is 7. Okay, so let's figure out delta x next, because that's part of the formula for dy. So delta x, that's a Greek letter, delta, and it just basically means the change of x. So this is a good formula to use here, right? X plus delta x equals the number here, 49.1. So x is always the good guy. So that's the 49, the one that we know. So I'm going to let x be 49 plus, we don't know what delta x is, but we have equals 49.1. And then we can tell by observation, isn't delta x going to be 0.1? So that's why I wrote that. That's why I wrote the 0.1 there. Because 49 plus 0.1 does give you 49.1. So we can conclude that delta x equals 0.1. Sometimes delta x is negative, but in this case it's obviously positive. Okay, now remember delta x is the same thing as dx. That's a good thing to remember because of this formula right here. Okay, and remember delta x is a small increase or increment in x. Let's find f prime of x now, because dy means the differential. So dy, the formula is f prime of x dx. So we already found dx, which is the same thing as delta x. Let's find f prime of x next. So remember, this was our f of x equals the square root of x. So what is f prime of x going to be? And I did that down here. F prime of x. Take the derivative of the square root of x, since that's what f of x is. And let's rewrite that radical x in more friendly terms with an exponential form as opposed to radical form. Easier to deal with exponential form. You can do stuff with it. So what is the derivative of x to the 1/2? Let's use the power rule. And we get this, 1/2 x to the negative 1/2, which we can rewrite as 1 over 2 times the square root of x. That's just handling negative exponents. You put it in the denominator. Remember, something raised to the 1/2 power is the same thing as the square root of. Now what you want to do is find f prime of 49, f prime of x. And x, remember, was the good guy, 49. So what is f prime of 49? All I'm going to do is plug in 49 for all x's in f prime of x. So we get this for the first step. 1 over 2 times the square root of 49, which equals 1 over 2 times 7. And that equals 1/14. Then dy, which I drew an arrow, we did this before, dy equals f prime of x dx. So dy f prime of 49 was 1/14 times dx, which we established as 0.1. What is 1/14 times 0.1? It's like, I could write 0.1 over 1. So what's 1 times 0.1? 0.1 over 14? And when you have a fraction, you don't want to see decimal points in it. It's not simplified. So let's multiply top and bottom by 10 to clear away the decimal point. And then that gives us the equivalent fraction, 1 over 140. So just like that, we found what dy equals. Okay, so therefore, that's a cool abbreviation for therefore, the 3 dots. Make sure it does not look like the face. That's a common mistake where you draw the two dots up top and then the one down there. Okay, so that means therefore. Therefore, the square root of 49.1, which we didn't know, is approximately, that's what the wavy equal sign means, approximately 1/140th more than the square root of 49. Because again, this is a dy. We figured out dy is 1/140th here. And okay, so, or I could write what's 7 plus 1/40th? 1/140th is 7 and 1/140th, or as a decimal equals that. Now the actual square root of 49.1 using a calculator is this number right here. Notice how close this is. This is the actual, close to our estimation using dy. So, and then let's just continue here. I just want to summarize here. So it's close indeed. So close indeed. So with the small increments in x, in other words, going from 49.1 to 49, there is a corresponding increment in y. And what was that corresponding increment in y? It went from 7, the square root of 49, 7, to the square root of 49.1, which was 7.007142. And that small increment in y is called dy, which is very close to the actual delta y. So dy isn't exactly the same thing as delta y. Remember, dx was the same thing as delta x. But dy is a very good approximation of delta y, and it's much easier to find dy than the actual delta y. And okay, so delta y, the actual delta y was, it's a change of outputs. So this is the actual square root of 49.1 by our calculator. And then minus 7 is that. So that's delta y, the change of outputs from the square root of 49 to the square root of 49.1. And then here is dy, which again is very close to delta y, which means the change of outputs. And that dy we got as this, which equals that. Notice how close these two answers are for the change in outputs. So dy, like delta y, measures the difference between outputs. Here, the answers of the square root of 49 and the square root of 49.1. All right, so that is differentials, and we'll see you next time.